Okay, so this is going to be our Unit 1, starting us off with kind of a recall from Integrated 1, some vocabulary and notation. So the first thing we're going to look at is being able to recall this. So this is going to be our assignment page. So I have it all the way up through our Unit 1 quiz. And so I just want to make sure that this is something that we're referencing so you can always anticipate when our quiz or a test is going to be. And I'll reference this in our videos frequently. All right, so first one up is we're going to recall what a point is. So the picture of a point is a location anywhere. We could put another point over here and another point over here, and each one of them comes with a name. So we could have B here and Z over here. The picture is the dot. The label here is A. The name would just be the capital letter, A, B, or a Z, so that we could reference each one of those by a single capital letter. It doesn't need the dot there, so we don't actually need that piece. The second one we're going to review is a line, and there's several ways that we can name a line. Most of the time it's going to be with one lowercase letter like this, where it's referencing that entire line M. The other one is with two capital letters, giving us a location. We know N is a point right here, and we know M is a point right here. The two ways that we could name that line using the points are NM or MN, which would capture the same line. The notation is above the two letters, saying we're going to go through these two. So we put a line with arrows above that as a notation, saying that it goes through location N, through location M, and through those 2 points. So not starting, not stopping. The third thing we're going to review is a segment. So this segment, again, has a location A, has a location D, and it's connected in between. The two ways that we can name this are using the two locations, AD and DA. Maybe I picked that, Andrea Dale. Actually, I don't think I did, but if I did, I kind of like picking my initials. So A to D, the notation is from location to location, just like we did up here, A, capital A, through D, capital D, but the notation is going to be different because we're not going through these points, we're starting and stopping. So the bar above tells us that it doesn't go through A and through D, it starts and stops to create that segment. Okay, our next review here, we're going to look at a ray. And so this ray is what's one of the building blocks of our angles. And I always think of it as kind of like a ray of sunshine. Did you guys do this doodle? Probably not with the arrows, but I always had like a cool sunglasses kind of guy over here that I always doodled when I was a kid. So a ray, again, we have a location J, so it's going to be part of the name. We have location K, that's going to be part of the name. But now we are only going through K. So we're going to just have a location that we start and a point that we go through. So J is a location, K is a location, but this is telling us we start at J and go through K. So this is one of the first ones where this would not work. So we wouldn't want to do that one. It also would not be appropriate to say, maybe we would go like this. This would not be another way to do it. So K to J and go the other way. We just read left to right, so that's how we're going to write our rays as well. Initial to the point that we go through. So even if we had one that was like this, where say I had A, B this way, this would not be alphabetical in my naming of this one. If I wanted to properly name this one, I do where it starts and what it goes through to kind of see, even though the visual picture of it might be going to the left, the name always goes right to left. It always goes left to right. All right, and our next one, we have an angle. Angles have different ways that we can name it. So my favorite one is just by the letter kind of in the middle of our vertex here, indicating this whole space here from this ray to this ray is creating angle 3. If this is the only angle at the vertex, we can name this angle K because there's no other angle being represented by this vertex K. The other two are by naming it, I call kind of alphabet soup, where we have to follow the angle here. So if I start left to right, the locations it goes through is T, K, and then A, with K being where it turns, just like it turns here, and angle 3. We can also name this going the other way. So similar to the line and the segment, we can name it going through A location through K, and that's where it turns to get to T. Anytime we have an angle, we want to make sure that we have that angle symbol included in our naming. The last one that we're going to look at is vertical angles. So even though this is the last one for now, we still will be referencing some other vocab and notation, but these are ones that come up pretty quick right when we get started. So if I wanted to name vertical angles, we have two intersecting lines here that cross each other at J. I like to throw in numbers because, again, if I want to reference angles, my favorite way is typically by putting a number inside to represent that space. Vertical angles are angles that are across from each other. And they form kind of an X, or what I think of as like that V for vertical. And so when we are across from each other, this would be coming in pairs. So the first set of vertical angles we have is angle 1 and angle 3. The second pair of vertical angles we have here are angle 4 and angle 2. The relationship they have here is congruent. And so that's going to be something that's important as we continue in this unit, looking at some more triangle relationships and figures that are saying, okay, are these the same angle or are they different? Vertical angles is always something that we can use to get a congruent relationship. Vertical angles are congruent, always. So our example, okay, we're not going to be doing many calculations in this unit, or I'm sorry, in this section. We're looking at just naming them. Name two intersecting lines. We want to make sure that we are using the diagram here and understanding that there are multiple correct answers. So what I put down as my example might not have been the exact same thing you saw there, but that's okay. As long as we're naming them correctly, that's really what we're practicing here. So on our first one, name two intersecting lines. So if I picked this line here and this line here, I'm going to change the color on it. I could name the first line A through J, and I'm going to properly name it with arrows above, and it intersects the red line E through G. E is a location on that second line. G is also a location on that second line. These intersect at F, but notice I didn't even use F in my naming. I could have, but I don't need to name four different points on here. I know that it goes through A and it goes through J. It captures C and F as well. Okay, if I look at part 2 here, where it says name 3 collinear points. All right, so collinear. Co means they share something, like a coworker shares work. Collinear means they share the line. So I'm looking for points that are all on the same line. So the first one I see here is C, E, H, B are all on the same line. This is just asked me to indicate 3 though, so I can pick any of those 3. B is a location that is on the same line as location E and H. On part 3, it says name 3 non-collinear points. Okay, so if collinear means they share the same line, non-collinear means that these are 3 points not on the same line. I cannot connect them with a straight line. So I'm just going to pick 3 locations that are not on the same line. So A, G, and K are not connected by one straight line. So I'm going to indicate those are my non-collinear points. So I have A is non-collinear with G. They could connect, but they couldn't also connect with K. So my three non-collinear points are A, G, and K. Keep in mind that there are multiple correct answers. Maybe you saw E, J, and L. Those would also be three non-collinear points. On the next part, now we're changing gears from lines and points to two segments. So segments, remember, are going to be two connected locations. So if I see E, E could be connected to C, where I start at E, stop at C. So EC is one of my segments I see. Another one could be F, starts here, ends at J. So FJ, with the bar above it, is also another segment. The notation above tells me the difference between a line that goes through them and a starting and ending point. On number 5, we're looking at two rays. So rays are going to be where we have an initial point and we go through something. So maybe here I see a starting location of C and I want to go through F. So again, we start with a location to begin with and go through a point. If I looked at another one, I could say D through E. This would be another ray. I started at D and go through E with my notation above it indicating that direction. On number 6, name a pair of vertical angles. Okay, so again, this is where I like to throw in angle numbers, angle 1, angle 2, angle 3, angle 4. Every location has 4 angles. So I'm going to put in all the angle numbers here. So I did 1, 2, 3, 4 at this intersection, 5, 6, 7, 8 at this intersection, 9, 10, 11, 12 here at this intersection. So my vertical angles are the ones that are across from each other, forming that X. So I'm going to look, maybe I see angle 4 and angle 2. This would be a pair of vertical angles where they're across from each other. Still, multiple correct answers. We could have said 5 and 7, 12 and 10, 9 and 11. Make sure that we're using our angle symbol because really about today is about that reminder of what we've talked about before and that notation. On 7, as we move to look at an obtuse angle. So an obtuse is an angle that is greater than 90 degrees. So I'm looking for an angle that is bigger than 90 degrees. Okay, so I see this angle here. I'm going to practice naming it, even though I erased those angles. I think it was like angle 7 or something. I'm going to practice with our other naming technique that would have these 3 letters that create this angle that I think is obtuse. So I'm going to use my angle symbol and then use locations 1, 2, and 3 to name it. So this is angle E, F is where it turns, to J, that creates that angle. I could have used C, F, G on the other side. D, E, C appears to be bigger than 90. H, E, F on the other side also appears to be greater than 90. B, C, F, again, multiple correct answers here. So what you see. If you have questions, let me know, and I can make sure that what you were seeing was also on the right path. And the last one, name an acute angle. So an acute angle is less than 90 degrees. So now we're looking for a smaller angle. I'm going to set up my angle symbol here, and maybe I use this angle right at the top, ACB. This angle appears to be less than 90 degrees. If I wanted to, again, I could, as long as I'm labeling my picture and I have something to reference here, I could use angle 1 here and say angle 1 is an acute angle. But I want to make sure that my notation is here. In fact, really, because I erased my angle 4 and angle 2, which I think I had up here, I would want to make sure that I have something referenced in my picture if it wasn't there to begin with. All right, so that is our first note session, kind of looking at reviewing vocab and notation. Thank you.